Okay, so today I am going to discuss the obviously the JAM 2025 paper. The answer key, official answer keys and responses are already out. So I will try to first do the NET 1 marks question, and eventually I will try to solve all the papers. So let's start with the NET 1 marks question. Okay. So the first question is that this is the first question. So if you have a problem, let me zoom a little bit. Okay, so they are saying that two solid cylinder of same density are found to have some moment of same moment of inertia about their respective principal axis. Length of second cylinder is that of 16 times that of first cylinder. If the radius of first cylinder is 4 semi, the radius of second cylinder is what? So this is a simple problem, and you should get 1 marks in this question. Okay, so basically they are telling that m1 r1 square by 2 is equal to m2 r2 square by 2. So this is the first thing, that a moment of inertia is fixed. Next things are then their density are fixed. So if we assume density is some rho, then rho m, what is cylinder mass? Mass is equal to volume into density. And what is volume? Volume is simply pi r square L, pi into radius square into length. So for this m1, pi 1 r1 square, that means it will become r1 to the power 4 into L1 is equal to rho pi r2 to the power 4 into L2, right? So now r1 to the power 4 is equal to r2 to the power 4 into L2 by L1 is 16, it is given. So R1 is equal to 2R2. So R2 is basically R1 by 2, that is 2 centimeter. Okay. So this is an integer option type. So you should fill 2 here. Okay. Now let's move to next question. Okay. So yeah. So the shortest distance between an object and its real image formed by a thin convex lens of focal length 20 cm. Okay. So if you remember the theory of convex lens can have real image, can have virtual image. It has only virtual image if you place an object which is placed in between the center and the focus. If the object is somewhere between center and focus, then the image will be virtual. Otherwise, in any case, the image will be real. Okay. So if you try to do it by intuition, just by guess, then you can obviously find one solution, that is if r is equal to 2f may be the solution. If we don't try to prove it and just do it by intuition, then you can tick it by 40 semi. But let's try to solve it actually, that when it will true that the distance will be minimum, okay, the shortest distance. So let's try to find it actually. So 1 by v minus 1 by u is equal to 1 by f, and let's say somewhere u is somewhere here, not between f and 0, because image should be real. So u is surely negative in this case. If you remember the ray diagram, if light ray is passing from here then going here, then this distance, if you measure distance from this and opposite to the direction of light, then the magnitude of this is fixed, and it will pick up an extra negative sign, because direction of light ray in this direction, and you are measuring distance from in this direction. So let's say distance is x, and let's say u plus v, that means your mod of u plus mod of v is d. D is the shortest distance, I am assuming. Okay, so 1 by d minus x plus 1 by x, I am assuming u has negative x. U is equal to negative x. Come with the sign. Okay, is equal to 1 by 20. Okay, so if you solve this, then it will be d 20d 20d is equal to d minus x into x is equal to dx minus x square, right? So what will be your d? D is equal to d into x minus 20 is equal to x square, and d is equal to x square by x minus 20. So this is your d, right? Now you have to minimize d. So differentiate d by x is equal to 0. But this is already a complicated function. So let's calculate 1 by d. 1 by t is x minus 20 divided by x square is equal to 1 by x minus 20 by x square, right? Now if d is shortest, then 1 by d is maximum. If d is minimum, then 1 by d is maximum. So you can differentiate dd of dx is equal to 0, but even you can differentiate d 1 by d into dx is equal to 0, doesn't matter, because if d is minimum, 1 by d is maximum, the differentiation will still goes to 0. So that means it is implies minus 1 by x square plus 40 by x cube is equal to 0. That means x is equal to 47. So if you do try to do it by calculus, then this will take a long, I mean some time, and you have to be very careful about the sign conventions also. And if you do it by intuition, then you obviously can find, okay, r is equal to 2f is something looking good. Okay, this is the only thing you can predict. Okay, so yeah, you can do it by intuition also, but this is the way. This is the right way. Okay. Now this problem. Okay. So consider two media 1 and 2 having permittivities epsilon naught and 2 epsilon naught respectively. The interface between these media is aligned along the xy plane, and electric field E1 is this, and the magnitude of the displacement vector D2 you have to put this value in order of epsilon naught. Okay. So let's first try to, so this is suppose aligned to xy plane. I mean if this is yx. So if this is the plane, suppose aligned to xy plane means it is parallel to xy plane. So this is the plane they are mentioning. So normal to this plane is surely k cap, right? So let's suppose this is the plane. So normal to the plane is k cap, right? Now E1 is given to you. It is 4 I cap minus 5 j cap plus k cap probably, yeah, minus k cap I guess, right? Let's see, it's minus k cap. Okay, and you know this is epsilon naught, you know this is 2 epsilon naught, you know, don't know what is e2 and d2. So let's use the boundary condition simply. So d1 perpendicular is equal to d2 perpendicular. So epsilon naught e1 vector dot k is equal to 2 epsilon naught e2 vector dot k, right? So that means now E1 vector dot k cap, it will simply pick minus 1, and there is an extra 2, and E2 vector dot k is simply picking the z component of E2 vector, right? So E2z is simply minus 0.5. Okay. And we know what another boundary condition, that E1 parallel is equal to E2 parallel. Okay. So what is the parallel of xy plane? Parallel of xy plane is the xy plane itself, not perpendicular is k cap, but parallel is xy plane. So E2, what is E2? E2 is simply the parallel component that is perpendicular to k cap. It is the parallel component I and j, the xy plane. So it will remain same, only the z component will change, right? So this is your E2 vector. And what is your d2 vector? Multiply it by 2 epsilon naught. So it will simply become 8 I cap minus 10 j cap minus k cap. Okay. So what is mod of d2? It is epsilon naught root under 64 plus 100 plus 1 is equal to root under 165. If you calculate this, it will come around 12.84. Okay. So you can, this will be the correct answer. And there is a range, I guess. Okay. Okay, so now let's move to next. Okay, so now this is another problem. G1 G2 are two ideal gases, T1 and T2 their respective temperature. The molecular weight of constituents of G1 is half that of G2. That means if M1 is the molecular mass of G1 and M2 is the molecular mass of G2, then M1 is equal to M2 by 2. They are simply mentioning that. If the average speeds of the molecules of both gases are equal, then assuming Maxwell-Boltzmann distribution, the ratio of T2 by T1. Now this is again a simple problem. So the average speed is root under 2kt by m, and they are mentioning they are equal. So it is simply telling that T1 by m1 is equal to T2 by m2, and m2 is simply 2m1. So T2 by T1 what? T2 by T1 is equal to 2. Okay, so this is a easy problem. You should get 1 marks here. Okay, so I am mentioning also, this may be a little confusing. Someone may do a mistake. So I am assuming they leave this problem. The third problem here, the electric field, magnetic field, they also, I mean, some may do a mistake because at the BSc level, some may do not familiar with the boundary conditions very well, I guess. So may do a mistake. So I am leaving 42 and 43 as most of the people, I mean, average students will do mistakes here. But these two questions, 41 and 44, you should get marks here. Everyone should get marks here. So I am also predicting what should be the cutoff step by step after doing each part. Okay, now this 45, an ideal PN junction diode if eta is equal to 1, ideality factor, operating in forward bias at room temperature of, and thermal energy it is 26 by 26 MeV. That means they are mentioning that KT by E is equal to 26 MeV. Okay, this is a standard value. Some books use 25, some books use 26. Doesn't matter. If the diode current is 26 milliampere for an applied bias of 1 volt, then the dynamic resistance of RAC. Okay, so let me first directly give you that. If you directly know the formula, you can do it very quickly. Okay, so RAC is basically 26 by IE. This is the direct formula, and how it will come I will show you. 26 by 26 is simply 1.00. You can put it 1.00. Okay, and I guess this should be the right answer. I don't know why they put two decimal places, maybe some other cause. So how can you fix this? Okay, so I is equal to I saturation e to the power EV by eta kt minus 1. This is the ideal diode equation. But eta is the ideality factor. They are mentioned that it is 1. So just put it here. Now, what is dynamic resistance? Dynamic resistance is RSE is equal to dV by di. Okay, so this is the dynamic resistance. Okay, V by I is the DC resistance. Okay, so at a particular instant you have some V, you have some I, and you put the value, you get RDC. But it will change with time, temperature and applied voltage. Okay, so change with temperature mainly. So RAC is the dynamic resistance, will give the instantaneous value. Okay, so di by dv is equal to is into e by kt into e to the power ev by kt. Okay, so kt by e, you can put this e in the denominator, and it is just 1 by RSC, and is e to the power ev by kt, it is approximately is equal to, not exactly is equal to, it is I. Okay, so I, this minus 1 is of course there, so you can account this, but most of the cases you don't need to account this. Okay, so it is I by 26 millivolt. And what is I is given in the question, it is 26 milliampere. Okay, so this will come at 1.00. And if you take this thing in account, I guess there will be some factor of 1 point something something. That's why they are asking for up to two decimal places. Okay, otherwise there is no need. This is the direct formula. Okay, so again, this is 45. Now let's next question, 46. In a two-level atomic system, the excited state is 0.2 electron volt above the ground state. Considering Maxwell-Boltzmann distribution, the temperature at which 2% of the atoms will be in excited state. Okay. So suppose this is ground state, this is excited state, and Maxwell-Boltzmann distribution suggests that e to the power minus e by kt is proportional to the number density or the population. Okay, so this is the number density, suppose. So e to the power minus e to the higher excited state is proportional to 2%. Then the rest of the things will be in the ground state. So 98% are in the ground state, right? So this is the scenario, 2 by 98. Okay, so 2% in excited state and 98% in the ground state. So if you calculate, then e to the power 0.2 electron volt by kT is equal to log of 14, sorry, not log of 49, it is 49. So you have given 0.2 electron volt, and K in terms of electron volt is already given. So you don't have to do any hard work also. K is already given in terms of electron volt. So electron volt will cancel each other, right? let's put this 10 to the power 5 here, and electron volt is already cancelled, so it is just log of 49. Okay, so if you simplify this, you will get your answer. Okay, so let me just quickly do it in calculator. Okay, so I am getting something 596.17, so I guess this will be in the range. Okay, so yeah, now move to 47. Right. Neutrons of energy 8 MeV are incident on a potential step of 48 MeV. As they penetrate the classically forbidden region, the distance at which the probability density of finding neutrons decrease by a factor of 100. Okay. So this will be a straightforward formula. So in the region, in the classically forbidden region, if E less than V, it is clearly the E less than V case. So in this region is classically forbidden region. But in quantum mechanics, there is some finite probability, and the probability will depend in the order of e to the power minus 2 k2 x. So x is the distance traveled, and k2 is the root under 2 mv minus e by h cut square. Okay, so this is k2. So it is mentioning that e to the power minus 2 k2x is decreased by a factor 100. Okay, so they are simply telling that 2k2x is equal to log 100. So this is fine. But the difficulty in this question is you have to find k2, and there is lots of things sitting here, h cut, m, v, e. Okay, and they are in mev, many, many things. Okay. So let me give you a very, very good idea that how to use these values accurately to simplify your life. Okay. So let us find k2. K2 square, let's say. So we can relate it, again take the root at the end, h cut square. So multiply a c square here. Okay, so this is the rest mass energy of the neutron. Okay, 2 mc square. So let me write it as e naught. Okay, v naught is 48 mev and e is 8 mev. So 48 minus 8, and in terms of mev. Okay, and h cut c whole square. Okay, now what is h cut c? H cut c, they are already mentioned, this is 200 MeV. Okay, and E naught is what? E naught is 1 GeV. 1 GeV is equal to 10 to the power 3 MeV. Right. So now let's look carefully. It is 10 to the power 3 into 40. And what is the unit of this numerator? It is MeV square. Okay, and what is h cut c? H cut c is 200 square into MeV square. So the units got eliminated. Okay. So you have to be very careful about the units. Okay. Right conversion of units should be needed, and the values are given accordingly. That's why they are given that h cut c is 200 MeV. You should know this trick of multiplying c square. Okay. So if you calculate this, it will come probably 200 square, and here is 4, 2, right? So K2 is root 2. So they are simply trailing that 2 root 2 x naught is log 100. Okay. So calculate x naught. Let me quickly do it. It will come around 1.63. Okay. So 628. So write accordingly if they are mentioning 2 decimal or 3 decimal, up to 2 decimal, so you can put it 1.63. Okay. Yeah. Now, oh sorry, not 46, it is 47. Sorry, this is not, this is 596.17. This is for 1.63. Yeah. At particular temperature T, the Planck's energy density of black body radiation in terms of rho T nu is this much. Nu is this much. And what is rho T lambda? Okay, in unit of 10 to the power 2. Okay, and C is given. Okay, so the thing is that if you know the formula, E nu d nu is equal to 8 pi h nu cube e to the power h nu by kt minus 1 d nu. Now the trick is, I mean the thing you should know from conversion to nu to lambda is that nu is equal to c by lambda. So d nu is c by lambda square d lambda. Of course there is a minus sign, but we don't care, we care about the magnitude. Okay, so conversion from this to this, okay, conversion from nu to lambda, e lambda d lambda will be 8 pi h. Nu is c by lambda whole cube, that will remain same. There is e to the power h c by lambda kt minus 1, but there is extra factor of c by lambda square into d lambda. So the e lambda will multiply, this is e nu, this is basically e nu, and there is an extra factor of c by lambda square multiplying here. Okay, this is the thing you should do. So now put the values. What are they given? 8 into 10 to the power minus 18, 8 into 10 to the power minus 18, and c by lambda square. So what is lambda? Lambda is equal to c by nu. So lambda square is equal to c square by nu square. So it is c nu square into c. So what is nu? Nu is 3 into 10 to the power 14. So nu square is equal to, so let's calculate it, 8 into 10 to the power 18, 3 square 9 into 10 to the power 28 by 3 into 10 to the power 8. Okay, so if you simplify, it will come 24 into 10 to the power 2. So your answer should be 24. Okay, so you should fill 24 here. Okay, so maybe I probably missed the 49 question, 49 number question. Okay, so probably I will do it in the next video. Probably I missed that 49 number question. Okay, so 49 number question is very simple also, I guess. No, I think I will not miss. Oh, sorry, this is 49 number question. It is in very low. It is, yeah, this is the 49 number question. The ratio, maybe you have difficulty to see this, but let's you can figure it out, I guess. You all have question papers. The ratio of density of atoms between 1 1 plane and 1 1 0 planes in a simple cubic lattice. Okay, so simple cubic lattice. So if you I mean, probably you know the formula, the planar density. Planar density is simply sigma is equal to nd by v. N is the number of atoms in the unit cell. So for SCN is equal to 1, for BCCN is equal to 2, FCCN is equal to 4. D is the distance between the corresponding planes. Suppose, I mean, D is equal to, if A is the primitive lattice vectors for all the three edges, then D is simply h square by k square plus l square. Okay. So for the 1 1 1 plane, you can correctly figure it out. It is in a by root 3 a cube, and for the 1 1 0 plane it will be 1 into a by root 2 a cube. So the ratio will be root under 2 by 3. Okay, so it will 0.816 something around it. Okay, so it will up to 2 decimal plates, so 0.82 will be good. The 50th question, the packing fraction of a two-dimensional hexagonal lattice having sides toward with atoms of radius r placed at each vertex at center. Okay, so this is also a standard problem. Okay, so it is a 2D hexagonal lattice, and you should know how to decompose it in triangles. Okay, suppose this is the center, so they all are equilateral triangles. Okay, all are side length A. There are six equilateral triangles. So if you assume the length is A, then 6 into root 3 by 4 A square is the area of this total hexagonal structure. And A is already 2R. Okay, so it is 6 root 3 R square. So you get the area. Now try time to find out the area of the total circles. I mean the atoms, 2D atoms. Okay, so this is something I am not very good at the diagram. So like this is the configurations, like there are six atoms here and one atom at the center. This is the kind of diagram. Okay, so this angle, what is this angle? This angle is 120 degree. All these angles are 120 degree in a hexagonal. Okay, so let's consider this atom. So this atom has a total area of pi r square. So if you complete the circle, this is the total area of the circle, that is pi r square. But only 120 degrees inside this hexagon. So the partial area which is inside this hexagon is pi r square into 120 by 360. That is pi r square by 3, right? Now, how many are this kind of atoms are there? One, 2, 3, 4, 5, 6. So you should multiply it by 6, 6 into pi square by 3. Plus, there is an extra full atom which is fully sitting inside it. So it will contribute total pi r square for this atom. So the total area of this all this partially enclosed atom plus this full atom, that is 3 pi r square. Okay. So the packing fraction is obviously 3 pi r square by 6 root 3 r square is equal to root 3 pi by 6. So if you calculate it, you will get 0.906, okay, approximately. So up to 2 decimal, then it will be 0.91. Okay. So this will all the solution of part 1, and I think there is no mistake in answer key for these problems. Okay, so let me now quickly tell you that how much should you score for as an average student. As an average student, how much should you minimum score? I mean, I am predicting what should be the cutoff for this part only. So 50 may be a difficult, okay, so you may not answer this. Okay, so I am considering the maximal possibility. 41, 49 you should answer. Okay, this 1 mark should you get. 48 you should get. 47, a little difficulty maybe arise in the calculation of this K2. What I show the technique that H cut. Where is that? H cut C square into MC square. Okay, so in 47 you may have little difficulty, so I am crossing it. And let's move to next one. 46, 46 is a good, I mean, not difficult, it's just simple formula. You should answer it. Okay, you should answer it. And let's move to now, this is 46, right? 46, 45. Okay, so what about 45? 45 I am crossing because some of you may know that retired equation. Okay, properly. This is a sure shot 1 marks. Okay, this is 44 and 41 is also you should answer it, and 43 you should also answer it. Okay, so you should minimum 5 marks you should get in this part. Okay, so yeah, this is for the part 1 solution, NAT part 1 marks question, and I will eventually come with other solutions. Okay, thank you.